When most animals stop moving, they do something that feels completely natural to us. They stand. Whether it's a dog resting in the yard, a squirrel pausing on a branch, or a horse grazing in a field, their bodies are designed to balance upright on their legs. But there is one creature that breaks this rule entirely. It doesn't stand like other animals. It doesn't perch upright. Instead, it flips the script on gravity itself. In this video, we're asking a fascinating question. Why do bats hang upside down? And as we explored that question, it led us to an even stranger truth. Bats can't truly stand the way other animals do. Their bodies reject the earth beneath them and instead embrace the sky above. So why is that? Why did evolution shape them into beings that rest, sleep, and even launch into flight from a position most other creatures would never survive? That's exactly what we're uncovering today, as we step into the world of one of nature's most misunderstood animals. When you picture a bat, you probably see that iconic silhouette tucked beneath a cave roof, wrapped in a cloak of wings, hanging motionless while the world turns quietly below. It feels strange, unnatural, almost eerie. But for bats, that upside-down posture isn't just a habit. It's the foundation of how their bodies function. Unlike most mammals, bats were never designed to stand upright. Their legs aren't built for support. Their feet aren't made for walking. They are built for something entirely different: flight. And that truth explains almost everything about their unusual relationship with gravity. To understand why bats can't stand like other animals, we have to look at the way their skeletons evolved. When birds developed wings, their transformation happened primarily in the arms and chest. Their legs remained powerful tools for jumping, landing, and pushing off the ground. Bats went in a completely different direction. Their wings didn't form from feathers growing outward. They stretched from their fingers. Their arms grew longer, their bones became thinner, and their muscles shifted to favor aerial control rather than ground strength. The legs were essentially left behind in evolution's redesign, becoming smaller, weaker, and rotated in a backwards bending direction. They don't extend downward to support weight. They point upward toward the sky. That means when a bat tries to stand, its body is fighting against its own structure. The joints don't lock into a stable position. The muscles aren't shaped to stabilize. Instead of balancing, the bat collapses forward. It's like trying to lean a ladder sideways. Gravity doesn't cooperate. On the ground, they wobble, crawl, or shuffle awkwardly because their anatomy simply rejects upright posture. They were never meant to live on flat terrain. They were engineered for suspension and flight. But here's where the story becomes even more fascinating. What looks like a weakness from a human perspective is actually one of the greatest survival advantages in nature. Because bats can't push off the ground to take flight, they needed another way to launch themselves into the air. Evolution provided the perfect workaround. By hanging upside down, gravity becomes their ally. When danger appears, or the night calls them to hunt, they don't need to leap or run. They simply release their grip, fall, and transform that drop into instant momentum. No fuel wasted, no warm-up required. Just drop and fly. This upside-down lifestyle works because bats possess one of the most extraordinary gripping mechanisms in the animal kingdom. Hidden inside their legs is a tendon-locking system unlike anything we have in our own bodies. When we grip something, we actively use our muscles, and when we relax, our grip loosens. Bats operate in reverse. When their body relaxes, their tendons tighten. The claws close naturally. The more they rest, the stronger their hold becomes. It's a biological braking system powered not by effort, but by stillness. That is why bats can sleep for hours without falling. It's why they remain hanging during storms. It's why even in death their bodies sometimes remain suspended. Gravity doesn't pull them down. It helps lock them in. If humans tried to live this way, our blood would rush to our heads, our muscles would seize, and we would last only moments. But bats have circulatory systems adapted for this inverted world. Their hearts pump efficiently while upside down. Their blood vessels regulate pressure differently. Even their lungs function in a way that supports hanging rather than standing. Their entire internal architecture is calibrated for a world where the sky is below them and the earth is above. Bats also gain something else from this strange posture: safety. Most animals survive by blending into their environment or outrunning danger. Bats survive by becoming unreachable. The predators that stalk most mammals, foxes, snakes, wildcats, rarely venture onto ceiling ledges or deep cave ceilings. Few animals can climb vertically into dark, narrow crevices or navigate the jagged stone chambers where bat colonies gather. By roosting upside down in places others cannot reach, bats disappear from the landscape completely. They don't just avoid danger, they rise above it. This unusual posture also allows bats to colonize environments that no other mammal can use. A flat-footed animal needs a solid resting surface. A bat can rest almost anywhere. Inside hollow trees, beneath cliff edges, under bridges, in abandoned mines, beneath roof rafters, on rugged cave ceilings barely wide enough to hold a palm. By not requiring the ground, bats unlocked an entire dimension of habitat that was previously unavailable to mammals. That flexibility allowed them to thrive on nearly every continent and spread across environments ranging from dense forests to desert caves to urban structures. But their inability to stand isn't just about gravity and bone structure, it's also about energy. Flying is one of the most demanding activities in nature. A bat's metabolism soars when it is in motion. To conserve energy, bats enter states of low activity called torpor. Their body temperature drops. Their breathing slows. Their heart rate decreases dramatically. During this fragile energy-saving state, standing upright would be impossible. Hanging upside down allows their bodies to remain supported without effort, even when their muscles are barely active. When entire colonies huddle together in roosts, their combined body heat forms a warm pocket of air. Hanging upside down maximizes close contact and allows thousands of bats to share warmth while maintaining position. What looks chaotic on a cave ceiling is actually an organized, thermal-efficient structure. Each bat plays a role in stabilizing the temperature and humidity of the group, forming a living tapestry of wings and fur designed for survival. Even their social lives function differently because of this posture. Hanging grants them flexibility to groom, nurse young, communicate, and reposition with ease. Mothers cradle pups against their chests while inverted, allowing them to feed and protect their young without touching the ground. Colonies exchange squeaks, vibrations, and wing movements as a form of communication, all while suspended like living constellations in the dark. There's another remarkable truth about bats. Not all of them hang in exactly the same way. Some species roost openly beneath tree branches where wind and sunlight pass through. Others hide in caves where light never reaches. Some grip individually, while others cluster in vast swarms that look like rippling shadows across the stone. But whether solitary or collective, every bat shares the same underlying limitation. The ground is not their home. Standing upright is not an option, and so the sky becomes their foundation. Occasionally we see videos of bats crawling awkwardly on the ground, dragging themselves forward or hopping clumsily. It's easy to mistake this for weakness. But the truth is, they were never designed for that world. Asking a bat to stand is like asking a fish to run. It doesn't fail because it is fragile, but because it belongs to an entirely different realm of movement. And yet, despite this limitation, bats are among the most successful mammals on Earth. They pollinate crops. They control insect populations. Some species disperse seeds that regrow forests after wildfires. Their upside-down lifestyle, as strange as it may seem, is not a defect. It is a masterpiece of natural adaptation. Their inability to stand created a new way to exist, a way that turned weakness into efficiency, vulnerability into refuge, and gravity into a launching pad. So when we ask, why can't bats stand like other animals? The answer is surprisingly poetic. They were never meant to. Their bodies evolved away from the earth and toward the air. Their legs became hooks. Their feet became anchors. Their world flipped, and in that inversion, they found their greatest advantage. What looks upside down to us is perfectly right side up to them. The next time you see a bat hanging quietly in a cave or resting beneath a bridge, try seeing it not as something strange, but as something extraordinary. A creature that rewrote the rules of movement. A mammal that surrendered the ground in exchange for the sky. And a reminder that sometimes, survival isn't about fitting in with the rest of the animal kingdom. It's about finding your own way to exist within it. Thank you for watching. If you have a question you'd like us to explore next, feel free to leave it in the comments below. We love hearing your ideas, and we may feature yours in a future episode. If you enjoyed this journey into the world of bats and want more stories about the hidden science behind everyday mysteries, don't forget to like, subscribe, and explore our other videos.